crash course series. This is session 1 on logarithms. So let's get started. So our objectives today are to learn what a logarithm is, along with learning essential logarithm facts, learn the properties of logarithms, and solving both easy and hard problems involving logarithms. So a logarithm is the inverse function of the exponential function. They help in solving equations involving exponents by translating multiplication of numbers into addition of their exponents. For example, b to the power of x equals a can be written as log base b of a equals to x. So let's start with an example. 5 to the power of 3 equals to 125 is our equation, and we want to convert this equation as a logarithmic equation. So we can write this as log base 5 of 125 equals to 3, because 5 to the power of 3 equals to 125. Let's move on. So on the right here is a Desmos graph of both a logarithmic function and an exponential function. The green figure is the exponential function, and the red figure is the logarithmic function. And they're both the same shape, but they're reflected over the line y equals to x, as all inverse functions are. So next, let's move on to properties of logarithms. All 8 of these are properties of logarithms, and they're really important to memorize because they can come in very useful when solving logarithmic problems. So this is our first logarithmic equation. We need to solve log base 2 of x plus 3 plus log base 2 of 5 equals 4. And we're solving for x. So first, let's write this problem out. Log base 2 of x plus 3 plus log base 2 of 5. And so we need to see what property will help us solve this equation. And we can see that property 2 is in similar format of this. So let's use property 2 and try to simplify this equation on the left-hand side. So using property 2, we get log base 2 of 5x plus 15 equals to 4. Now we can move this 2 here, and we get 5x plus 15 equals to 2 to the power of 4. And we can continue to simplify this as 5x plus 15 equals to 16. Moving the 15 to the right, we get 5x equals to 1. And then we can divide by 5 on both sides to get x equals to 1/5. This is an easy example, and logarithmic problems only get harder from here. Let's do another easy example. So we have y times log of 25 is equal to log of 625. So we need to see what property will help us solve this equation. And property 1 seems to help us, because log a base a of b to the power of n equals to n times log of a b. So this can be rewritten as y times log 5 squared, and this can be rewritten as log of 5 cubed. Now using property 1, we can get y times 2 log of 5 equals to 3 log of 5. Now if we get rid of the log of 5 by dividing by on both sides, we'll have y by itself. So we have 2y is equal to 3, and then dividing by 2 on both sides, we get y is equal to 3/2. And this is the answer to problem 3. Now let's move on to a medium logarithmic problem. So we have a calculator that only calculates logarithms in base 10. And I want to calculate log base 4 of 6. So what can I do to calculate it on my calculator? So we need to scan the properties of logarithms to see something that will help us here. Property 5 seems to help us. Log base a of b divided by log base a of c is equal to log base c of b. So we can set a equals to 10, and that will help us. We'll get the division of 2 log 10 expressions, which we can input into our calculator. So we have log 4 of 6, where c is equal to 4 and b is equal to 6. And now we can plug these values onto the left-hand side. So we get log of 10 of 6 divided by log 10 of 4 equals to log base 4 of 6. And we can input this into our calculator, and we can do this because both expressions are on the term of base 10. And we'll get our answer on the calculator. Now let's go into a hard problem here. You can see that we've added an extra property here, property 9, and this will come in handy for this problem. So our problem is p is equal to log base b of log base b of a divided by log base b of a. So the simplest thing to start here is we can just move this to the left hand side. So we get p times log base b of a equals to log base b of log base b of a. Now we can use property 1 and we'll get log b of a to the power of p is equal to log b of log b of a. And this is what we're trying to solve for. So the most logical thing here to do is move this b here. So we get a to the power of p is equal to b to the power of log b of log b of a. Now this is where property 9 comes in. Let me erase to make some more space. And so this is where property 9 comes in handy. We can see that property 9 looks just like this, except instead of a here, we have log b of a. So if we use property a, we get a to the power of p is equal to log base b of a. And that's our answer. Okay, that's it on logarithms. Make sure to join us on our next session on trigonometry. But for now, that's it. Thank you for watching.